right, so this is what I'm going to consider lesson 4.4. Okay, so the fourth video of Unit 4, I guess, on multiplying and dividing rational expressions. And one, you want to remember that if it's division, that means the same as multiplying by the reciprocal. It means the second fraction flips. Then you're going to factor everything you can and cancel things out. When it says diagonally, it means one has to be on the top and one has to be on the bottom. It doesn't actually have to be diagonal. It could be the top and the bottom of the same fraction even. There are a couple kind of odd ones in this bunch, as that usually tends to happen, but we'll take those as we come. This is on the bottom of the same page of notes as when you were doing simplifying. And the IXL lesson that we're going to take a look at is 05. All right, so keep that in mind. So this first one, I see it does say division, which means the second fraction is going to need to be inverted, the reciprocal. It's going to flip top and bottom. And then the first part, we're going to factor. So we don't usually see things written like 8 minus k, but for the moment, I'm going to leave it. Sometimes we need to switch that around and like divide it by -1. That would be the same thing as saying -1 times k minus 8, because it would change both of their signs. And it's always legal to change the order as long as I take the sign with it. So that may be something we need to do, but at the moment I'm just going to leave it alone. The bottom is difference of squares, so that's a k plus 8 and a k minus 8. And then you see like, ooh, maybe I am going to want to do that. And then the second fraction is getting flipped over. It doesn't factor though, because they're already just binomials. But the k plus 8 ends up in the top and the k minus 8 in the bottom. And then I see that this k plus 8 and that k plus 8 can cancel out. And while it does not initially look like it, that anything else can cancel, if you just see that the signs are wrong, then we can do what I just did up here, which basically means this is going to get factored as -1 times k minus 8. So, I mean, I guess technically it first becomes -1 times -8 plus k, and then I switch the order. Then these could cancel, whether I use this one and this, or I use the bottom of this second fraction. But you cannot, it's a 1 for 1. I can't cancel both of them. And so this final answer is going to be -1 over k minus 8. And that would be the final answer for that. All right, so don't let that part with the -1 worry you too much. I promise if there's more examples like that on IXL, we'll look at them together. So over here on the right, so the first one doesn't factor, and the first fraction never flips. Whether it's multiplication or division, the first fraction stays oriented the same way. The second one needs to flip. It's going to change places. So when I factor the bottom, it's going to get written on the top. When I factor the top, it's going to get written on the bottom. So they are switching places there. So that numerator is a difference of squares. It factors as k plus 1, k minus 1. And that denominator, two things that multiply to be +3 but add up to -4, would be -3 and -1. And then now we just cancel everything that we can whether it's in the same fraction or two different fractions, as long as one's on the top and one's on the bottom. So k minus 3's, k plus 1. And if everything cancels, what do you think that is? So remember, when things cancel, it's like k plus 1 divided by, so it's all, they all are ones. Anytime we cancel, it's really a 1. So it's just 1 times 1 times 1. So this is just 1 over 1. The whole thing is just equal to 1. So anything divided by itself is equal to 1. And a fraction, remember, indicates division. So that final answer would be equal to 1. So those were both division, so the second fraction did have to flip. As you see on this next page, which used to be a homework page for us, there are some simplified problems, and then when we get down to number 8, it's a multiplication. And so with multiplication, if you can factor, you should. There is no flipping going on, though. In number 8, nothing needs to be factored, but the t plus 2 and that t plus 2, they can cancel out. And this t squared and that t squared, they can cancel out. And I just end up with a 3 on the top, basically 3 divided by 1, which is just 3. So there's no variable in the answer. Other times it will be multiplication, but I might have to factor both my numerator and my denominator. All sorts of factoring. So this is like potentially 4 different factoring problems. Actually, I'm going to go on down to number 10, where there really is 4 different factoring problems. So if you have 2 fractions, then you have 4 different factoring problems. So the numerator there, again, this is in your notes. Hold on. Got that too far down. It's not going to let me. There we go. All right, we'll look at 10 and 11 here. So the top of this would be x minus 7 and x plus 5. So again, 2 things that multiply to be 35, negative 35, but they're going to subtract and have a difference of 2. In the bottom, take out the common factor, so 2x, or just x squared, my bad, leaving us with 2x minus 3. And then my other fraction, the 4x cubed minus 9x, well, that has an x, and then it would be 4x squared minus 9. Ooh, but that's a difference of squares. So this is going to factor again to be 2x plus 3, 2x minus 3. Now, I'm not real big on rewriting my whole problem again. I'm just going to trade that stuff for what I wrote above. And then in the denominator, 7x minus 49. Not quite the difference of squares because the x is not squared, first off, and 7 is not a perfect square. So just take out the common factor of 7, and then this would be x minus 7. And now, remember, this stuff's already been traded for the things above where it factored more fully, more completely. Now I can look for things that cancel. So x minus 7, bam. This 2x minus 3, 2x minus 3. Now, there's not anything to cancel with the x plus 5. One thing that sometimes people overlook is that this x could knock the squared off of that x. Because remember, x squared, when I see x squared, that's really the same thing as x times x. And so that might help you see why that knocks the squared off of that. So now what's left in the numerator is x plus 5, 2x plus 3. And you're just going to leave it written in factored form like that. You do not need to multiply it back out. And then in the denominator, there's an x and a 7. Now we can combine that pretty easily. That's just 7x. But we do not need to distribute what's in the top. You would just walk away from that the way it is. So 11, a little bit less factoring to do, but the second fraction needs to flip. So first fraction is going to stay. So I'm going to do this part on top in purple. So I have R and R. I know my signs are different because it's a -8. So I have a +4 and a -2. That way they multiply to be -8, but add to be the 2 in the middle. And then in the denominator, I'll put that in green just to help us see the difference of what I'm factoring where. So to multiply to 3 and add up to 4, I've got 3 and 1. And then our other fraction is going to flip. So the top is going to become the bottom, and that R minus 2, hopefully you got this written down, or you can back up. I'm going to get it out of our way. That R minus 2 does not factor, but it does move to the denominator when I use the reciprocal. The 3R plus 3, this one is going to just GCF, and that would be R plus 1. And then now I want to go and look for everything. Now that I've inverted or used the reciprocal for the second fraction, changed that to multiplication, everything is in factored form. Now I start looking for things to cancel. And I see that there's nothing that can cancel with the R plus 4, but R minus 2, R minus 2, R plus 1, R plus 1. So then I'm just going to write my answer. If there is a whole number, I would write it to the front of the parentheses, like that. And then in the denominator, just R plus 3. And since there's not something outside of that parentheses, I don't need to use the parentheses in the denominator. The fraction bar acts like a big grouping symbol. All right, so let's go over and take a look at what the IXL lesson looks like. There are some things in the IXL lesson where nothing cancels, and so we're just writing it as one fraction. And so at the beginning, kind of anticipate that. You might want, again, a separate sheet of paper so you can write down a few of these examples and then stick it in with these. All right? All right, so as promised, this very first one is going to happen, that nothing really cancels. It says divide it by h squared. So remember that division means the same as multiplying by the reciprocal, and if that second thing is not really a fraction, it's like h squared over 1. So when I flip it over, the 1 is on top and the h squared is on the bottom. I cannot cancel out any of these h's because the 2 on the right are both being added and subtracted with something. They're not just being multiplied. So the only thing I can do to write this in quote simplest form is just multiply across, put that up there. I'm going to write my h squared outside of some parentheses. Now, this would be the same thing as if I did this, but I believe, and I'm going to test it, I believe that you can just leave it in the factored form on the left, which really saves you from potentially making a mistake. So, that's how I'm going to put it in. Pretty sure. I worked through some of these earlier, but at the beginning I just skipped over them. Again, remember, I am recorded, so you can go back if I zipped past something. Use your little button so that you get your exponent, be sure that then you like use tab or you click so that it goes down so that your next part is not all in the exponent. And then h minus 5. Oh, I don't want too many parentheses there. All right, everybody see what I've done there? That agrees with what I had written. And IXL says that's just fine, so I did not need to distribute. So if you see, for instance here, it's just multiply, and nothing is going to cancel, and I think it's going to accept my answer if I just write these two things next to each other. Although this would make a very nice x squared, 9x squared minus 25 over 4. So if you did, go ahead and multiply those together, because I can recognize that's a difference of squares pattern. If you did go ahead and multiply them together, and you gave the answer as 9x squared minus 25. So all that stuff is in the top, and only the 4 is still in the bottom. And it'll take that too. Okay, so there's a couple different ways that things are still in proper form. So the 6n is going to be in the top with the n minus 1. Your choice. You can just slide that n minus 1 into some parentheses. I like to put what's not in parentheses in the front. And that 5 is in the bottom. I'm going to experiment here a little bit while it's me instead of you, right? What if I just wanted to keep it in the same order? What if I did parentheses n minus 1 and then the 6n? You do have to have the parentheses. I can tell you that for certain. If you leave out the parentheses, it's going to be wrong. But let's see if we could just go left to right. And we can. So more than one way. Looks like when you get to the high 20s, you're going to have to actually start factoring something, which is going to be more like our examples. So those first problems were just a little easier, actually. So the 4j plus 1 is on top, 6 is on bottom. We're dividing by this stuff. So that stuff is going to be in the bottom, and I'm going to put a 1 on the top. So anytime I'm dividing by, anytime I just have something that's like a whole number or a polynomial, it's always understood that it's over 1. And then if I need to flip that to multiply by the reciprocal, then the 1's going to be on top. And now I'm going to be factoring this. So I have 12j squared minus j minus 1. So this would actually be asterisk factoring, so they're going to jump right in on us. So that's negative 12, negative 1, 12j, 12j. So if I want to multiply to be negative 12, 1 has to be plus, 1 minus, but when I subtract them, I have a difference of 1. Negative number's bigger, so negative 4, positive 3. And then I have some reducing to do. So it looks like this one reduces to 4 and 1, so 4j plus 1. And the other one reduces to, I'm sorry. 4, so 3j minus 1. And it should not be surprising that one of those factors is the same as that other numerator. That way something cancels. And then what's left is our answer. So our answer is going to have a 1 on the top, and then in the denominator, a 6 on the outside, and 3j minus 1 inside some parentheses. So 1 on the outside, or 1 on the top, 6 on the outside. So you'll need your fraction, 1 on the top, 6 on the outside, and then 3j minus 1. Okay, so I had to do some factoring there. Now, sometimes it's going to look like maybe things could factor, but then they don't, or they factor but nothing cancels. So for instance, in this problem, the bottom does factor to be u plus 1 and u plus 9, but is that helpful? It's not helpful because nothing cancels with that. The u plus 1 and the u minus 1 cannot cancel. And so, since nothing cancels, I can just go back to using my original thing. I just need... Oops, sorry, I don't need that. And the 8u squared could go first, but I could put the factored away down here. Or I could just retype it the way it is. So since nothing canceled, to simplify this, it just becomes one fraction with the 8u squared in the numerator. The u minus 1 does need to be in parentheses though. And you can write the 8u squared first or second. If it makes more sense to you to just leave it in the same order, that's fine. Again, I can't stress enough, if the top of that fraction already said you had two terms, those two terms need to be inside some parentheses when you multiply it times something. Also, be really careful. Watch what you're typing, like that. Don't leave that way. Make sure before you click enter that it says what you think it should say. Okay, IXL's not picky about those extra spaces. Ta-da! Alright, so, but don't think you can just do that with every problem. You have to see if they could factor and cancel. So in this case, the numerator has a common factor, and then that would be 5d minus 4. The 3d minus 2 is still there. This says divide it by this stuff, so that means that stuff's going to go in the denominator. 1 on the top. And then I see, oh, hey, this can cancel. Don't be tempted. I know you might be tempted, but do not try to cancel those d's. This d at the bottom isn't just 3d. He's 3d minus 2. So we can't cancel a d out of that. So this is d on the top, because d times 1 is d, and then 3d minus 2 in my denominator. So a d on the top. That's what was left after I canceled. And then in the denominator is still that entire expression 3d minus 2. I'm going to try. It is okay if you want to put that in parentheses down there. It's not necessary, but I'm pretty sure, yeah, it's not going to mark it wrong. Okay. So if you have a binomial in your numerator denominator and you put it in parentheses, it's okay. So again, factor what you start with. 7q in the denominator. Let's see, 7 goes into both of those. That would be 2q plus 5. And then I'm multiplying this by 2q plus 5, which means it's in the top if I'm multiplying by that. So those two cancel out. The 7q's cancel out. Remember, when things cancel, they're leaving behind ones, really. So this is just, if everything cancels, the whole answer is just a 1. Ta-da! So in this case, it's the part we're dividing by that's going to factor. So it's going to go in the denominator with a 1 on the top because it said divide. We know we multiplied by the reciprocal. They have a 5 in common, d plus 5, and then those would cancel, and what's left is my answer. So 1 over 3d plus 5. If you want to type 3d plus 15, that's okay. So 1 on the top, 3, I can type 3 parentheses d plus 5, or I could have typed 3d plus 15. But if you choose to distribute, and for whatever reason you multiply wrong, then it's wrong. Okay, so the safest thing is probably to just walk away from it like this. So if you look at the homework that I would have given you on paper, you would have seen things more similar to this, harder problems where there's more factoring to do. In this case, both of these on the right are going to involve doing the asterisk. So 8 times 1 is 8. This is 8x and 8x. This is a 6. They are both plus. And if you like to do grouping instead, we should still come out to the same place. You could pause me and make sure that indeed we do. So what multiplies to be 8 and adds to be 6 would be 4 and 2. Those both reduce. So that becomes 2x plus 1. And the other side becomes 4x plus 1. And that was the numerator. It is now going to be in the denominator because it was division. And then I'm going to have to do something very similar for the denominator. So then for this, which is going to end up in the top, it's 12, 6x, 6x, negative 7, so they are both negative. So what multiplies to 12 and adds up to 7? Yeah, 3 and 4. And they're both minus. And then that reduces to be a 1 and a 2, and to be a 3 and a 2. So that's 2x minus 1 and 3x minus 2. And then don't forget we had this guy over here originally, 4x plus 1, 3x minus 2. So the 4x plus 1, bam, gone. The 3x minus 2, bam, gone. These two cannot cancel out because one has a plus and one has a minus, so they are not exactly the same factors. So that's what I'm putting. 2x minus 1 is in my numerator and 2x plus 1 in my denominator. 2x minus 1 over 2x plus 1. 2x minus 1, 2x plus 1. All right, so one more example. So again, always factor everything you can. So the 5n minus 4 does not factor. Oh, hello, get rid of that. 5n minus 4. The denominator, they have a GCF of 2, and then 5n plus 2. This one, 5n plus 2, doesn't factor. And the denominator, those two have an n in common, right? So there's going to be an n on the outside, and then it's the difference of two squares. So 5n plus 4, 5n minus 4. Now I look to see what can cancel. 5n minus 4, bam. 5n plus 2, bam. So there's nothing left in the numerator that's not canceled out, so the numerator is a 1. And then 2 times n is 2n, and then 5n plus 4. So everything that's left is in the denominator. Again, this is the same thing as 1 over 10n squared plus 8n. It would not be wrong to do that, but if you mess up multiplying that out, then you just took a perfectly good answer, did more work, and then got it wrong. So it's okay to leave it in factored form. Factored form is still simple, simplest form, all right? As long as there's nothing that can still be canceled out. So 2n times 5n plus 4. So 1 over 2n 5n plus 4. And then if I looked ahead at this one, I actually see that I would want to do a GCF on the top before I factor the trinomial. So just know, all the kinds of factoring that we've done, any of those things could be a part of what you have to do. Okay, so we are not going to have class tomorrow on Tuesday. This is actually the lesson, back that up. Depending on which term you're taking this, but this is the lesson for 05. If you're taking it in term 3 of 2020, this lesson is for part of Wednesday's lessons. All right. Okay. Thanks.